So in this video we are going to discuss another important concept from artificial intelligence, that is a-star algorithm. So a-star algorithm, it is a informed search procedure which uses the heuristic function. If you take breadth first or depth first search algorithms, they are called as blind search algorithms, in which we don't have any knowledge. Simply we will visit the nodes and check whether the node is goal state or not a goal state. If it is a goal state, then we stop the procedure, otherwise we will continue. They are called blind search. But in case of the a-star algorithm, we will use the heuristic value. It is based on the domain knowledge. It is used to find out optimal path from the starting node to the goal node. It evaluates the next node from the current node using the function, that is f of n is equal to g of n plus h of n, where this g of n is the cost from the initial state to the state at which the current node, and h of n is the estimated cost from the state at node n to the goal state. The steps of a-star algorithm: first of all, we keep two lists, one is open list and another is a closed list. Place the start node on the open list. Select a node, that is n, from the open list which has smallest value of f of n, and place it on the closed list. If node n is the goal state, then return success, we can stop the procedure. Otherwise, expand the node n, that is generate the possible successors of that particular node, and evaluate the f of n for that particular node. F of n is equal to g of n plus h of n, and place it on the open list. Fourth step, go to step number 2, repeat until getting the goal state. So the open list contains the list of nodes which are to be, that is, explored in future. Select the best node. So the selection, it can be that is done with the help of checking the value of f of n. So the least f of n value, that is selected. So the node contain the least f of n, that is the best node. So in the closed list, the best node that is taken from the open list, that should be, that is included in the closed list, and check it is the goal state. If it is not the goal state, we have to, that is, check the next node. So this is the steps of this algorithm. Now let us see how this given problem can be solved using this algorithm. This is the given graph, and in which we have to find out the optimal path from the initial state to the goal state. So this is the goal state and this is the initial state, starting state. Let us consider, we start from the initial state. So the initial state is A, and from this we are going to, that is, a traverse. So if you explore from A, we have two possible nodes. We have that is node B, and another node is that is C. Now we have to calculate the f of n. So the f of n can be calculated using this formula, g of n plus h of n. So in order to, that is, reach from A to B, the cost is, that is, 1, and the value of the heuristic function that is given in the table. So therefore B, it is 6. So it is G of B plus H of B. This is F of B. F of B is equal to G of B plus H of B. So this G of B, it is the cost to reach B from A. So that is, this is 1, and the heuristic value of B, it is given in the table, that is 6, it is equal to 7. Similarly, on other side we find out the value. From A to C, the cost is it is 4. The cost of reaching C from A, it is 4. Now calculate the value, that is F of C is equal to G of C plus H of C. So the value of G of C, it is nothing but 4, and what is the H of C? See the table, H of C, it is 4, so that is 8. Now two nodes that is generated. So from the initial node, the two nodes generated, and also their functions are calculated. So initially these two nodes will be, that is stored in the open list, and from that we have to select the best node. You have to select the best node. So which is the best node? The minimum value. So which is the minimum value? So this is the minimum, 7 is the minimum value. So we have to start to explore from this node, that is B. If you explore from B, we have two different paths. So one is a path to D and another path to C. Again we got this value, that is C. So this is D. So what is the cost of reaching C from B? It is 2. B to C, it is 2. So now find out the value, that is a function. Calculate the function for this C, that is F of C. It is G of C plus H of C. The value of G of C, it is, you have to add these two values, that is A2, that is C, it is 1 plus 2, that is 3, plus H of C, C value, that is 4. So it is nothing but 7. So this one side is calculated. Next side we have to calculate. Reaching D from B, it is cost is 3. Okay. Now calculate the value, that is F of D is equal to G of D plus H of D. So G of D, it is 1 plus 3, that is 4, and H of D, you take it from the table, that is, so it is equal to 7. Now both these values will be, that is placed in the open list, and you have to select the best one. If you compare all the leaf nodes, we have that is C is a leaf node and D is a leaf node, and another leaf node is here. Comparatively, you have to select the best one. So best one is nothing but the minimum value. So which is the minimum value? This is 7, this is also 7. So you can select any one of these two nodes, not this one. Okay. So if I select this one from C, so the next possible node is E. So cost of reaching E from C, it is 5. So now calculate the function of function value for E, that is F of E is equal to G of E plus H of E. So G of E, you have to calculate this A to B and B to C, then C to E. So it is 1 plus 2 plus 5, it is nothing but 8. Then H of E, you see that the value, it is 4, so which is equal to 12. Okay. Now you can compare all these leaf nodes. This is 12 and this is 7 and this is 8. So the least node, the node with the minimum value, it is nothing but D. So now we have to explore from D, and every time you have to, that is, check that whether it is a goal state or not. So C is E is not the goal state, So now we have to that is explore from D. What is the node? That is from D. You have two possible nodes, that is two possible ways. One is G and another is F. So this is F and this is G. So cost of reaching F from D, it is 2. So now calculate the function for this F of F is equal to G of F plus H of F. So G of F it is 1, 4 plus 2, that is 6. Then H of F it is 1, so which is equal to that is 7. So similarly calculate for G. D to G it is 4. Now calculate the value G of F of G is equal to G of G, capital G, plus H of G. So this G of G, it is 1 plus 3 plus 4, so it is 8. Then the heuristic value for G, it is 0. So now we got the value, that is 8. So again now you can compare these two. All the leaf nodes you can compare. This is 12 and this is 7 and this is 8 and this is 8. If you compare all the leaf nodes, so F is the minimum value, F has the minimum value. So now we can explore from F. So from F you have, that is G. This cost of traveling from F to G, it is 1. So now find out the value, that is G of G plus F, H of G. So see the value G of G, it is 1 plus 3 plus 2, that is 6 plus 1, that is 7. 7 plus H of G is 0, so it is nothing but 7. So now we can compare all these results. So this is 7, this is 12, this is 7 and this is 8 and this is 8. So comparatively only this value is minimum. So every time we are checking whether this is the goal state. Now we are checking whether it is the goal state. So yes, it is a goal state because it has a value that is 0. So further we cannot explore anything there. Okay, there is a goal state. There is no more connection from G. Okay, so G is the goal state and verify that. Now find out the path, which is the minimum path. The minimal path, it is A to, minimal path is A to B, then B to D, then D to, that is F, then F to, that is G. And so this is the optimal path. And the cost of reaching the goal state from the initial state, the minimum cost is, that is 1 plus 3 plus 2 plus, that is 1, so that is 7. So in this video we have discussed what is A* algorithm, and also I explained the various steps of A* algorithm and what is the importance of this open and the closed list. And I explained this algorithm with the help of this example. I hope you understood. Thank you. Keep watching.